Hi everyone, in this video we will learn about the Infinite Monkey Theorem and program concepts from the theorem in Python. Before we get started, I will review the Python modules I will use in the notebook. These include random, string, time, and matplotlib. I will now import the modules by running the first cell. First, I am going to explain the Infinite Monkey Theorem. The Infinite Monkey Theorem outlines a scenario where a monkey, given infinite time, will randomly type and reproduce any text almost surely. For example, a monkey will eventually randomly write the works of William Shakespeare given an infinite period of time. The basis of the theorem lies in probability theory. An event labeled as almost surely to happen means it will happen with a probability of 1 given an infinite number of trials. If the number of trials is finite, then the outcome that a monkey will write a Shakespeare work is no longer guaranteed, and the probability is less than or equal to 1. Now I am going to go into the mathematical proof for the theorem step by step. First, we make an assumption that the keyboard utilized has 26 keys represented by k. There is an equal probability that the monkey will type any of the characters on the keyboard. For a single trial, the probability of typing the target text t depends on the number of keys in the keyboard k and the number of characters in the text n. A successful outcome where the monkey correctly writes the text starting at the ith character is represented by a sub I. The probability of a successful event is given by the following equation. Since the trials are independent, the joint probability of typing the text correctly in multiple independent trials is the product of individual probabilities. Given an infinite series of keystrokes, the probability that the text will be typed at least once is given by the following equation. Using the second Borel-Cantelli lemma, we can show that if the trials are infinite and the events a sub I are independent, then the probability that the text is typed by the monkey is almost surely 1. The probability of typing the text t in any specific block of characters n is given by the following equation. The probabilities of the infinite trials are summed with the following equation. This shows that with infinite trials, the probability that the text will be typed at least once is 1, which guarantees that the text will be typed almost surely. Now we can apply these concepts within Python. I will quickly go over the assumptions we will need for our experiment. First, we need to define our characters. I am going to limit the simulated keyboard to the lowercase letters in the English alphabet, which gives us a key size of 26. We also need to ensure that the keystrokes or the selection of the characters are independent of each other and are uniformly randomly selected. We will utilize the choices function from the random module to implement the random selection of characters. I am going to create a Python function to estimate the number of iterations needed to generate a word randomly. I will name the function num_iters per word, and it will take two parameters, a word in string form and the size of the keyboard, which by default I will set as 26. To estimate the number of iterations needed to generate a word randomly, I need to take the keyboard size and raise it by the length of the target word. Let us utilize our function. I am going to set my target word as chimp, and then I am going to print out the number of estimated iterations needed to randomly generate our target word. Based on our calculation, it will take over 11 million iterations to randomly generate our target word chimp. Now that we have a numeric estimate of how many iterations it will take to randomly generate the word chimp, we can generate the word computationally with Python. I am going to call on the string module to retrieve all the ASCII lowercase characters and save them into a variable called letters. I will also initiate a variable called iterations, which we will use as our counter. I am going to time our code block using the time module to see how long it takes to randomly generate our target word chimp. Now I will start a while loop. The loop will continue to iterate until the random word generated is the target word. I am going to randomly generate a word using the random choices function. The choices function will select the characters randomly from our letters variable. The number of random picks will be set equal to the length of our target word. We will increase the iterations variable by 1 each time we generate a new word. We have an if statement that checks if our randomly generated word is equal to our target word. If the random word is not equal to our target word, the while loop will continue to iterate. If it is equal, then the while loop will break. In a print statement, I will print out the number of iterations it took to randomly generate our word, as well as the time it took to generate the word. For a code block, it took around 4.4 million iterations to randomly generate the target word, and the code block took 5 seconds to run. This is less than our numeric estimate, and there will be times where the iterations will be less than or greater than the numeric estimate to generate the random word. What I am going to do is run our computation over 100 iterations. I will save the number of iterations needed to generate the target word into a Python list. Then I will plot the Python list onto a histogram using matplotlib. Depending on the speed of your computer, this could take 10 to 20 minutes to run this code block. Now that the iterations have finished, I can plot all the data in a histogram. On the y-axis, we have the count of the iterations. The red dashed line is the numeric estimate for the number of iterations needed to generate the word chimp. We can see our histogram is skewed, and there are a significant amount of runs that took less than 11 million iterations to generate our target word. For our final experiment, we will see how many estimated iterations are needed to randomly generate 2 words. I am going to create a Python list named multiple targets, and I will save the 2 words in the list, chimp and fun. When we run our function, we will see it will take over 200 billion iterations to randomly generate these words in order. I was not able to run this on my computer. It most likely would take a full day to generate these 2 words. This illustrates the issue with trying to generate words randomly with finite time. It takes 24 hours to generate 2 target words randomly. How long would it take to generate Shakespeare's Othello, which is 26,450 words? If we also want to include punctuation and capitalization, it will take even longer. Thanks everyone for watching. I hope that this video was helpful. In the references section, I included references you can check out if you want to learn more about the Infinite Monkey Theorem and the proofs behind it. If you found the video helpful, feel free to like and subscribe. You can also connect with me on LinkedIn, X, GitHub, Medium, and Odyssey. I also have a new podcast called The Aspiring STEM Geek, which you can check out on YouTube, Spotify, Apple Podcasts, Audible, and iHeartRadio. Thanks again for watching and happy coding.